We're going to talk about sections 4.1, 4.2, 4.3, and we're talking about triangle congruence. I'm going to read the first statement. It says, if CDEF is congruent to KLMN, what are congruent corresponding parts? The two different parts are angles and sides. So we have angle C is congruent to angle K. And it's helpful to use the statement. You see how you have C corresponds with K. We also have angle D is congruent to angle L. Angle E is congruent to angle M. And we have angle F is congruent to angle N. The sides, we can also use the statement, and I'm just going to do one of them here. We have segment CD is congruent to segment KL. So segment CD is congruent to segment KL. What you can say now is segment DE is congruent to segment LM. Segment CD is congruent to segment LM. The next one, we have segment EF is congruent to segment MN. Segment EF is congruent to segment MN. And of course, we have the last one, which might be hard to see, but it's going to be segment CF. Segment CF is congruent to segment KN. If triangle UVW is congruent to triangle EFC, what is the measure of angle FEC? The measurement of angle FEC corresponds with the measurement of angle VUW. So you know that's 51 degrees, and we know that those are corresponding angles, and those angles are congruent because of the statement, because it says triangle UVW is congruent to triangle EFC. So angle FEC is equal to 51 degrees. Suppose it is given that angle C is congruent to angle B. Angle D is congruent to angle A. Segment AE, which I wrote right here, I put the marking, segment AE is congruent to segment BE. And segment CE is congruent to segment DE. Does that prove that triangle CDE is congruent to BAE? Are congruent? Well, this segment and this segment are congruent. So that means that these two angles are congruent. These two sides are congruent. So that means that the angles are congruent. And they said that C was congruent to B, so that's 2 markings. And they also said that D is congruent to A, that's 2 markings. So we know that this right here, angle CE, is a vertical angle, and we know that, angle CED is a vertical angle. We know that angle BEA is a vertical angle, that's congruent. So yes, you can say these two triangles are congruent, because if these two angles are congruent, then these two sides are congruent, and these angles are congruent, so these two sides are also congruent. So we have side, angle, side, angle, side is a reason why triangle CDE is congruent to triangle BAE. Now, this angle is a vertical angle, and we know that this is going to be that marking, and this angle is the same as this side. So we can also say that this side is congruent to this side. So we can also use side, side, side to prove that the two triangles are congruent. Is triangle XYZ, and I want to make sure that this is the right statement. We know that X corresponds with T, and we know that Y corresponds with S, and we know that Z corresponds with R. So the way it's written, it should have been, is triangle XYZ congruent to triangle? We have X corresponds with T, S, R. So I rewrote the statement, and we know that each corresponding side is congruent. So these two triangles are congruent because of side postulate. That means that this side is congruent to this side. That's a corresponding side. This side is congruent to this side. That's another corresponding side. And this side is corresponding with this side. So that's another corresponding side. So we have three sides that are corresponding, right? We also know that angle X is congruent to angle T. And we also know that this right here is the included side. There's the included side, and they also have this angle congruent. So it's also congruent because of angle, side, angle postulate. So for this problem, there's two ways that you can prove the triangle's congruent. Using side, side, side. That means there's three sets of corresponding sides, and the other one is angle, side, angle postulate. What other information do you need to prove triangle GHK is congruent to triangle KLG? So you're going to write down what you know. So we do this in class. We ask ourselves, we look at the picture, what do we know? We know that segment GL is congruent to segment KH. And the question I always ask in class, why are those two segments congruent? Because of the marking. The marking tells us that they are the same measurement. Now you notice that there's two triangles, and I'm going to go ahead and highlight the two triangles. So here's that one triangle, and then the other triangle is the green one. And you notice that the two triangles share a common side, don't they? If they share a common side, then we know that segment GK is congruent to segment GK. That's called reflexive property. So I'm going to go ahead and write two markings. So what you know is we have two sets of corresponding sides that are congruent. What do we need for side angle side? We need the included angle. We need the included angle to be congruent. And you might ask, what is the included angle? This is the included angle, and this is the included angle. Why it's called included angle? Because they share this side and this side, and that's why it's called included angle. This is called included angle because they share this side. So what angle do you need to prove using side angle side? You need the included angle. So we're going to write what we need. So I'm going to put need. We need angle, and you got to make sure you name it right. L, G, K has to be congruent. L corresponds with H. Angle H. L corresponds with H. K. L corresponds with H. G corresponds with K. So it's going to be H, K, G. So it's going to be angle L, G, H has to be congruent to angle H, K. What would you use? Would you use side, 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 or side angle side to prove the triangle is congruent? If there is not enough information to prove the triangle is congruent, by side, 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 or side angle side, right? Not enough information. Okay, so we need to list what we know. We know that this segment is congruent to this segment. How do we know? because of the markings. We also know that this segment is congruent to this segment y because of the markings. And then you notice the two triangles. Here's the first triangle, here's the second triangle. They do share a common side. So that side is also going to be congruent. And I'm going to use 3 because I'm going to use the markings to differentiate the different side measurements. So for sure, we can use side postulate to prove the two triangles congruent. Now, in the case of side postulate, you do not have enough information. And you might be saying, what do you mean not enough information? You needed at least the included side here. So, the included angle. So this would have to be this angle and this angle to use side, or the other included angle. So we couldn't use side postulate. We can use side postulate because we have 3 sets of corresponding sides. Directions. Check which congruent postulate you would use to prove that the two triangles are congruent. So you notice that we have these two triangles and we have 3 sets of corresponding sides. So definitely we can use the side postulate. Now, we can't use the side, angle, angle, or angle, side because we don't have a corresponding angle that is congruent with each other. Number 8, what we do have for this problem is we have this side congruent to this side because we have the markings that was given to us. We also know that this angle is congruent to this angle. We call that the included angle. That's the included angle, and we do have this side that they have in common. So we're not able to use the side postulate because we don't have this third side congruent. That third side corresponding side. So we can't use that. Now we don't have 2 sets of corresponding angles, so we can use this one and we can use this one. So the only one that we're able to use is going to be the side postulate. Side, corresponding side, included angle, and the side that they share. So that's why the two triangles would be congruent. So number 9, we have 2 triangles, and we notice also that they do share a common side. And like I told you in the last example, if they share a common side, then I can put 2 markings there. We have this side is congruent to this side. How do I know? Because of the markings. So we don't have that third side congruent. And that would have helped us by using the side postulate, but we don't have that third side. So side is not going to be used. Now we do have 2 angles. We have 2 pairs of included angles, so we can use angle, side, angle. And we can also use side, angle, side. So we can use those 2 sets of postulates to prove. Number 10, we have this side that's congruent to this side. We have this angle and this angle, which is the angle, which are the vertical angles. They have congruence. They also have this angle and they have this angle congruent. So definitely side would be out. Now it's between the last 3. Do we have side, angle, side? No, because we would have had to use, for side, angle, side, we would have had to have this one congruent to this side, but we don't have that. So unfortunately, we can't say that. So it won't be side, angle, side. Angle, side, angle, yes, we have this pair of angle congruent, we have this pair of sides congruent, and this angle. So it definitely will be angle, side, angle. It will not be angle, angle, side. This is a sort of different proof than the ones I've given you. We're going to go ahead and list the things that we know for sure. We do know that segment TS is congruent to segment WV. Why? Because of the marking. and it's also given, so I'm going to write given. What else is also given? Angle S is congruent to angle V. That's given. I think there's several things that are given. Segment UV is congruent to segment VW, which is congruent to segment WU. So WU is congruent to UV, which is congruent to WV. So all those sides are congruent, and that's going to be also given. Now, you notice that triangle UVW have all the sides congruent. By definition, that's equilateral. So definition of equilateral triangles. Equilateral. Lateral means side. Equal means equal, so it's equal sides. Now, number 5, we have triangle UVW is equal angular, and that's by definition. So equal means equal, angular means angle. We do know that angle V is congruent to angle W. That was given. So, okay, so we have angle S is congruent to angle V. We also know that segment TS is congruent to segment WV. So, and we know that these angles are all congruent. So, how do we know that the two triangles are congruent using triangle RST is congruent to triangle UVW because of angle, side. Angle, side. Angle, side. What's given to us? C is the midpoint of segment BD. So that's the midpoint. Then the distance from B to C is the same distance from C to D, by definition of midpoint. That upside down T means that segment AB is perpendicular to BD. That means that it will be a 90-degree angle. Okay, so segment AB is perpendicular to BD. We also know that segment BD is perpendicular to DE. And like I've been telling you in class, this angle, and this angle are congruent because of vertical angles. So just by looking at it, we've already proven that the two triangles are congruent. The positive would be angle, side, angle. Number 1, C is the midpoint of segment BD. That's given. That's given. Segment AB is congruent to segment BD. Segment AB is perpendicular to segment BD, and segment BD is perpendicular to segment DE. That would be given. They gave us that. Number 3, segment BC is congruent to segment CD. That's definition of midpoint. Angle BCA, so it's this angle, is congruent to angle ECD. So that by definition is vertical angles. And we know that vertical angles are congruent. Vertical angle theorem. That's vertical angle theorem. Angle ABC and angle EDC are right angles. And that's by definition of perpendicular lines. Definition of perpendicular lines. Remember that if two lines are perpendicular, they form a 90-degree angle. Angle ABC, which is showing us that little box there, that is a right angle, and this is also a right angle. And we know that all right angles are congruent. I'm going to write that symbol. And then number 7, like we said earlier, we were talking about it. Triangle ABC is congruent to triangle EDC. And the reason is it's angle, side, angle, postulate. Given to us, segment LT is congruent to segment TR, and that's given. angle ILT is congruent to angle ETR, and that was given. 3 is IT is parallel to ER, and that was given. So yeah, there was 3 given statements. So number 4, we have angle LTI, so I'm going to put 2 markings, is congruent to angle ERT, and I'm going to go ahead and use 2 markings, okay? Do you know why? You just have to ignore those 2 segments, IL and ET. The transversal is segment LR, so it's going to be because of corresponding angles. Corresponding angles are congruent. Corresponding angles are congruent. And now you can tell me why the 2 triangles are congruent. Triangle LIT is congruent to triangle TER because of angle, side, angle, postulate.